Number 10. The Astrolabe. The astrolabe is an ancient astronomical computer that has many uses, including, as told to us by Wikipedia, locating and predicting the positions of the sun, moon, planets, and stars, determining local time, giving local latitude, and vice versa, surveying, and triangulation. The astrolabe was used during classical antiquity, the Islamic Golden Age, the European Middle Ages, and the Renaissance for all of these purposes. The early astrolabe was supposedly invented by Apollonius of Pergam around 220 BCE, which means that the astrolabe has been prevalent throughout history for over 2,000 years. Astrolabes can be purchased or built today and can be used with precision on our modern night skies. We are going to watch a brief clip from a video given at a TED conference about the astrolabe, its history, uses, and functionality. You can find the complete video on the official TED Talk site, and I would highly recommend watching the video in its entirety.
So an astrolabe is relatively unknown in today's world, but at the time, in the 13th century, it was the gadget of the day. It was the world's first popular computer, and it was a device that, in fact, is a model of the sky. So the different parts of the astrolabe in this particular type, the rete corresponds to the position of the stars, the plate corresponds to a coordinate system, and the mater has some scales and puts it all together. If you were an educated child, you would know how to not only use the astrolabe, you would also know how to make an astrolabe. And we know this because the first treatise on the astrolabe, the first technical manual in the English language, was written by Geoffrey Chaucer. Yes, that Geoffrey Chaucer in 1391 to his little Lewis, his 11-year-old son. And in this book, little Lewis would know the big idea. And the central idea that makes this computer work is this thing called stereographic projection. And basically the concept is, how do you represent the three-dimensional image of the night sky that surrounds us onto a flat, portable two-dimensional surface? The idea is actually relatively simple. Imagine that the Earth is at the center of the universe, and surrounding it is the sky projected onto a sphere. Each point on the surface of the sphere is mapped through the bottom pole onto a flat surface where it's then recorded. So the North Star corresponds to the center of the device. The ecliptic, which is the path of the sun, moon, and planets, correspond to an offset circle. The bright stars correspond to little daggers on the rete, and the altitude corresponds to the plate system. Now, the real genius of the astrolabe is not just the projection. The real genius is that it brings together two coordinate systems so they fit perfectly. There's the position of the sun, moon, and planets on the movable rete, and then there's their location on the sky as seen from a certain latitude on the back plate. So that's just one use. It's incredible. There's probably 350, 400 uses. In fact, there's a text that has over 1,000 uses of this first computer. On the back, there's scales and measurements for terrestrial navigation. You can survey with it. The city of Baghdad was surveyed with it. It could be used for calculating mathematical equations of all different types, and it would take a full university course to illustrate it.
The astrolabe is a computer, a calculator, a perfect measuring mechanism based on a geocentric, stationary model of the Earth. This piece of artistic and scientific brilliance needs no accolade, nor pomp or circumstance to announce its own craftsmanship, for its modern-day workability itself proves the genius of its design. A very profound question we must ask ourselves is, if the Sun is traveling at roughly 500,000 miles an hour, and the Earth rotates around it at roughly 66,000 miles an hour, how is it even possible to map and track the same set of stars for thousands of years? If we are to assume that the ancients created this calculator with a complete lack of understanding the true heliocentricity of our solar system, and merely created this calculator of the heavens as understood from their perspective and viewpoint, how is it possible they could have crafted such an instrument that maintains such precision over thousands of years? To somehow think that an instrument of such a high and accurate degree of calculability merely works today out of dumb luck or by accident is rather obtuse. Whoever created this instrument, whatever culture or person made it, their knowledge and ingenuity has withstood the test of time. It would seem that the heavens and the working of its cycles have been known and measurable for a very, very long time.